Okay, this is problem 14, dimensional analysis. This is a problem that is an exercise in algebra, knowing your common units for these variables and being able to see if, using your algebra to see if they are dimensionally consistent. Now, just because these equations are given there doesn't mean that they will be actually legitimate equations. It just is like a fail-safe, kind of like a to check, like if the dimensions don't work out, then you know it actually absolutely cannot be an equation. Now, in order to actually be a real equation, then you have to have some physics behind it, and you will be given the physics equation sheet. It will be given to I'll email it out. It'll be in Google Docs, and it will also be on Lon Kappa in the main document section, and I will put it at the top of this next unit. But okay, so let's first write down the units that are common for these. Now, it's not the only units, but they are a common type of unit that we will use for it. So position, so this is position, stands for position. And a common unit would be m for meters. Velocity, a common unit would be meters per second. Okay, time, a good unit that we will always use, well, we'll use a few others, but is seconds. Well, it's an S, and S stands for seconds. Okay, S, seconds, S. And now acceleration is a meter per second every second. So it's the change of your velocity, so a time change for your velocity. We can easily rewrite this as meters per second squared. So that's acceleration is meters per second squared. Okay, so we're going to use these things right here. We're going to plug them in and see if they're okay. So first equation, A equals x over v. Let's see if that's dimensionally okay. So we have meters. We're going to plug meters per second squared into there. And we're going to plug meters into x and meters per second into that. So it's right here. We did. So when we simplify this, top fractions, top times top over bottom times bottom, this is meters over second. Meters over second squared. As soon as you could tell it's no good, just say it's no good. Look, there is no algebra that makes this, you could hope to do to even make this correct. It's incorrect. See, meters, this squared versus this squared. That's no, so this is not equal. Does not equal, no. So this is false, or actually incorrect is what they want to be correct or incorrect, right? So this is incorrect, okay, for the first one. Let's do another color, and let's do another one. Let's do x equals a times v squared. Well, this is in meters, equals meters over seconds squared times meters over seconds, and that is squared. See, that velocity is squared. All right, so meters equals meters over seconds squared times, that's meters squared over seconds squared. Okay, and continuing on, and we have, this would be meters equals meters cubed. When you multiply that out, it's meters cubed over seconds to the fourth. This is Noah's, seconds to the fourth. That is no way, shape, or form correct either, so this one would be correct. Okay. And let's look at so get this one, do the fourth one, and we will do it right here. A equals v squared over x. So this is meters over second squared equals meters over seconds squared over meters. Okay, meters over seconds squared, and this is meters squared over seconds squared over meters. All right, so now what can we do? Well, this is division right here, right? So I'm going to rewrite this side over here, meters over seconds squared. Now this side is the same as meters squared over seconds squared times 1 over meters, because this would be divided by meters, so invert it and multiply it. And this cancels with this. So this would be meters over seconds squared, and this is meters over seconds squared. Check. So this one could possibly be correct. That was this one here. So that's how you check those. I'll leave you to check the rest. Good luck. Email me with any issues.